Hi everyone. Technical debt and why it will ruin your software. And here you can see a really known monument, and it's located in Italy, more specifically in Pisa. And it's called Leaning Tower of Pisa, or just Pisa Tower. This building has a very interesting story behind it, because it was built on the 12th century, and due to a soft ground which could not sustain the weight of the monument, it started to lean. Okay, the structure was stabilized in 2001 after 8 years of work. One fun fact is, one of those reworks and fixes, in fact, made the leaning worse. Well, I don't know if you guys already passed through this, but I already did a refactoring that makes the problem worse, so I can blame them. And now, I hope you have 2 questions in mind. First one, why the Pisa Towers relates to technical debt? And am I Italian because I am saying about Pisa? I don't know. The first one you know till the end of this talk, and the second one, no, I am not from Italy, I'm from Brazil. Actually, I'm from a really distant place from Italy. I'm from a city called Recife, where this accent that you're hearing is Portuguese. So Recife is a city that has the best carnival in the world, and at least 7 people here agree, because every Brazilian speaker that has in this conference are also from Recife. So it's really nice. Okay, my name is Luan Fonseca. I am working with Django since version 1.2, almost like 10 years already. And I'm the founder of an open source project called speakerfight.com, which we manage almost all meetups and conferences for the Python community back in Brazil. And also I'm a software engineer at LabCodes, which LabCodes is a software studio that's based in Brazil, and we specialize in creating custom web products fitted for specific needs, and we believe that software should be built by fulfilling clients' and user expectations. Our software is always aimed at solving problems and optimizing process. It's an incredible honor for us to be part of this conference, giving talks and sponsoring, because I have a talk today, Nikki did that yesterday, and Renato will be on Thursday, I think? Yeah, okay. Tomorrow, tomorrow, thanks. And okay, the agenda of this talk will start with a short story about John, showing the reality of an everyday programmer. Then we will go find out why technical debt is always seen as a bad thing, and who should be responsible for that. After that, we will go through some solutions that are not so good, and we can check another that can be healthier for these problems about technical debt. We'll discuss if it's lucrative for the companies to deal with technical debt, and what Ward, the guys that coined the concept of technical debt, and based off everything like that, we'll discuss what can programmers get beyond profit on dealing with technical debt. Okay, John the programmer. This is John. John is a senior software developer, always with a ton of work to do. John is a 5-star programmer with years and years of expertise in Django. Suddenly, a new project appears on John's tasks. This new project needs to have a payment system, social authentication, and integration with a third-party shipping service. The due date for that, for everything like that, was like 1 month. But John is an awesome employee, which always delivered his tasks. He went there, took the project, and delivered in time. After that, when the rest of his team went there to review his code, we found that John's code have some problems, like inconsistent payment bugs. Sometimes the shipments weren't being processed, and the authentication, the service authentication, were too naive on checking the social accounts. Okay, John knew that his code had some bugs. But when John was close to the due date on delivering that, another project appears on the John schedule. So he hadn't time to fix those problems. They had to deliver the project the way it was, but John is positive and kept thinking, okay, in the future you'll come back and fix everything. Spoiler, we all know that this won't happen, right? So after the review, the team found some problems on his code, like the code responsible for the payments on his app were not flexible enough to accept different currencies. If the shipping service is down for any reason, the delivery could not happen. Also, users with deactivating account, like if I deactivate my account on Facebook and try to sign in on John's project, it will work, which doesn't make sense. Besides that, all the code was not tested as it should be. And that are some points that we call technical debt. And why is that? Because as he shows a first-time solution, because of the delivery date is too close, the code had some problems, and the team accept that. We are okay with some problems in the code, because in the future, we think that we will do some changes. In the future, if this business logic on the project changes, the cost of changing John's code will be higher, because people will need to fix new issues and everything that they accepted as a bad thing, as a not so good thing. So that's the moment when technical debt was introduced on John's code. What happened in Pisa Tower is closer to what we understand as technical debt. Started with a few problems, and suddenly those problems escalated so quickly that past some time, it will fall down. The same happens with our softwares. With us, usually it's more visible during the process, because through the development process, we are feeling that some features and bug fixes are taking more time than it should take. So we are used to think that having some level of technical debt on our software is a bad thing. I mean, usually it is, but we can see it as a strategic move, because if we can have fast deliveries because of some technical debt that we allow it to have, it's awesome for our product. The major issue on that is when we forget that we did this in the past and then come back to fix it. Imagine that technical debt is like the mac and cheese from yesterday. If you have like 1 or 2, it's okay. But after the 12, it may become a problem, right? So, accepting that it's a trade-off, we can move fast and pay the consequences for that decision later. It's a really common thing to do for us. I don't know how many of you already pay the consequence from that mac and cheese, but remember that the cost increases over time. So if you identify with any of those situations on your day-to-day tasks, it's really okay as soon as we have our backlog, some dedicated time in the future to come back and fix. And that's a really common scenario on delivering new things on a day-to-day sprint, that you accept that situation and, okay, on the future you come back. If you look on the Martin Fowler technical debt quadrant, which I highly recommend you to check out later, we can see easily where John is, because he's on the top part of the quadrant, being reckless and prudent, because he knew that didn't have that much time to implement a better solution, but also addressed that in the future he will come back and fix. So he's kind of in the middle. When we focus on the name that we are repeatedly saying, technical debt, we are guided to think that it's a developer's issue for some reason, because we are the programmers and we created and it's technical and it's a debt and we need to pay. Well, the problem is that sometimes software is a result of the entire structure of processes in some company. Also, the entire industry have changed this since Ward created the term in 1992. So as in John's scenario, the problem of that not so good code that he wrote is more a management or a product team issue than his, because they don't give them enough time to improve, to create a better solution. Because we know that John is a good developer, but he needed to be deliberated on delivering some, on forgetting about some problems in order to deliver in the date that was scheduled to him. And so sometimes the bottlenecks that are creating technical debt in your software doesn't come directly from the technical team. It can be from other parts of the company. Like the management team may not be up to date on the development team speed and velocity, so they can schedule more things than your team has hands to do it. Also, the product team might not have given a big picture plan for the developers, so they are not able to anticipate things on the architectural side. And even the UI and UX teams may have been like too far on the development process from the devs, so they can create unfeasible experience experience on the design, and might be creating more bottlenecks to the development team to deliver. Like we are I don't know how to say that. Okay. Also, we can't forget that sometimes we need to blame ourselves for bad decisions, because if you if you are choosing a new framework for a new project and you're just choosing the newest hyped framework that has, also we didn't give enough attention for a framework that's dying, and we still pick that, we need to accept that was our consequence, or accept that as our decisions. Or even if we know that our application is not well tested, and we don't do anything to fix it, it's also our problem and we need to deal with it. Okay, how can we deal properly with technical debt? After defining all those problems we have in our applications, we need to see what are the possible tools that can help us to fix those problems. Imagine that if they stopped working on the pizza tower and bring everything down to rebuild it, the chance of the same mistakes and even new ones mistakes could appear on the new tower is really huge. Not even think on the amount of money that was spent to bring everything down and rebuild it. Also, in the pizza tower, if they just postpone problem by adding more people to try to hang the tower on the other side to prevent it to leaning, it will not be sustainable. And in fact, if we relate this to software development, it's worse, because if you add more people to work, like, okay, we decided that the core team will work on features and bug fix, and we will bring a new team to work on technical debt. That's the worst scenario, because the people that are getting into, they don't have the context of your software, they don't know the stack, they don't know how your team works. So your core team will need to explain them the context and everything like that. So that's the worst scenario. Don't do that, please. What happened on the pizza tower was exactly like that. The towers were leaning, and then they decided to stop the tourism until it was fixed. So if we did that to our software, it can be a good thing, but it can be a challenge to convince your managers to do, hey, we will spend 3 months just cleaning up the house and fixing technical debt instead of doing new features and bug fixes. It can be really hard to convince, but if you can do that, it's awesome. But we can emerge a new problem on that. If we have these moments of stopping everything and cleaning everything, it is not sustainable, because imagine that if you are spent like 4 months working, and then you stop 1 month to fix technical debts and some architectural problems. After 4 months, you need to stop again. So the better solution for that is to create a culture in your company of refactoring in order to avoid that stopping and fixing and stopping and fixing. Okay, if we just create a new board on our Jira or Pivotal or any task tool that your team uses, if you just create a new board for technical debt issues, after some time, it may get invisible for the team. Because imagine, like, if your day-to-day backlog is already invisible, you can see just like 10 tasks on your backlog. Imagine one that's separate from the main one. So it's not that good idea. Okay, what can we do? So, however, those are solutions that more people do. We can think on better solutions. So, what options are those? We have some, based on everything we see, we need to come up with feasible solutions for dealing with technical debt. The impact is a process of identify, mark, plan, act, and test on technical debt problems. As it says, the first one is all about finding it. So we need to look our code and ask for the devs that has more awareness on the code where we can find some technical debt points. Then the second one, we need to make sure those candidates are visible for the team by creating text on a board marked as technical debt issues, for instance. And we should also set a priority on those tasks. And if you are using Jira, for instance, Jira has a mechanism that over time, it's increasing the priority of these tasks. So it's really aligned with technical debt because technical debt costs are increasing over time, so we are working together. Okay, and based on that, if we mark those tasks, we need to stick to a plan and really stick to it in order to work in a healthy way to deal with technical debt and still delivering things, which is the hardest problem, I think. After that, we should act on decreasing, like fixing those debts. And the most important part is the last one, because as any refactoring process, we need to test that we didn't break any behavior of our software. I got that strategy from a book called Refactoring for Software Design Smell, Managing Technical Debt. It's a really good and easy book. Okay, if you don't know how many tasks you should put on the backlog of your team, of your own company, we should just use Pareto principle, where just 20% of the team's productive is assigned to those technical debt tasks, and the rest can be used for like features, bug, or any other technical stuff that your developers team works. And if your process has some big releases, like we have 2 weeks sprints and 1 release, you can do a post-mortem meeting after that just to discuss. It can be a quick one, just to discuss like the technical debt, things that we faced, or we introduced on the code during that sprint. That's nice because you can make the candidates for technical debt tasks earlier. You make them visible earlier, so we have less cost on those tasks. And those are 3 examples of possible solutions, but I highly recommend you to be really critique about everything and see what best suits you, because you need to fit that on your day-to-day schedule or culture of developers. So. And let's dig deep on the economical view of cost of working and dealing with a system with some level of technical debt. So this is a chart that I fall in love with from day one that I seen this. There is this talk from J.B. Reisenberg, on YouTube you can find this. It's the economic of software design. It's amazing, 1.5 hours, but you can totally see it. And that talk, he explains the cost of the next new feature on your software. And how can we decrease the uncertainty of that cost? Because if I go to anyone here and say, hey, how much your team takes to deliver a new feature? We can say that. We say 2 weeks. Yeah. I don't know. And then this chart explains why that's so hard to be explained, to have a real number on that. And this chart, if we look on it, it has a comparison of 2 lines, where one of those is creating a software from the beginning with design and without. As we can see, the growth of the cost of software that were built without design, without thinking about refactoring, good practicing, and design in general, it grows really quicker than the blue one. Even if the design-first software architecture has a higher cost, if we compare the beginning costs, the blue one has a bigger cost in the beginning, but after, through time, this amount is mitigated. It really pays off. So if you write your software without design, you are betting that this dashed line moment will never happen, because when that moment happens, the cost of implementing the next new feature will be higher than rewrite everything on your software. So if you want to bet on that, it's okay, but you can think about design and prevent that. Okay, poor quality software has become one of the most expensive topics in human history. Last year, CISQ did a report on US software costs, which was calculated considering legacy code, massive failure, cost of trouble and canceled projects. And for us to just to have a notion, this amount is about 2/3 of the total health expenses in 2018 in the US. That's how much is the cost of doing bad software. Programmers spent in average about 3.8 hours a day on debugging bad or low-quality code, or if a code is that hard to maintain or read. So imagine all that money being used for like better wage, social initiatives, training, and personal improvement. We can use that money better. This is Ward. This is the guy that coined the term technical debt. There's a short talk about 4 minutes of him explaining the technical debt concept and where it came from. I really recommend you to look on that. And he created that concept on 1992, the same year I was born, using a financial metaphor to explain for non-tech people the implied cost of additional work. Everything that we know today about good practice on software, agile, everything like that passed through Ward before. Also, Ward brought the wiki concept, like if you have Wikipedia today, it's because Ward did it in 1990 alguma coisa, it's something. And also he's an activist on agile and design patterns. So if we explain his concept, we can see something like that. And the definition of the debt metaphor, even if we have a great code with the best practice applied, that doesn't mean that we have a low technical debt. What he's saying is that technical debt is not a technical thing. If the code isn't aligned, if you do your code with less decoupled classes and design patterns and everything, that doesn't mean that your code doesn't have technical debt. Because the main argument on his concept is that technical debt is about the domain language and your software. If the code isn't aligned with the domain of your project, we will always be on a technical debt, because we will always continue to grow our software without thinking, and worse than, without not giving back knowledge that we gain through time. I mean, if you start to work on a project, on a new project today, after 2 years, you have a completely different knowledge about the domain. If you don't bring that domain, that knowledge on domain back to the software, you are creating technical debts also. So, what you have beyond profit, besides like saving money and delivering things fast? There are several things that we can identify as point of troubles on your life caused by dealing with technical debt on a day-to-day job. Atrophy of the team's technical ability is a really important one, because who here already had or still have some code running on a deprecated framework or Python 2, like unimaginable. And it's really a common scenario for us, and that's hard to deal with, because we need to accept the consequences of that deprecated software. Sometimes we need to copy and paste code in your own code base to avoid of some bug or something like that. Or even worse, usually we fork the original project, uploading in your GitHub, and start to install it from there and fixing from there. So we have a lot of difficult scenarios to work on a deprecated code. Besides that, we could face some compatibilities issue with new tools, like if you want to use Heroku or something, product as a service deployment tool for a deprecated framework, it probably won't be that integrated as Django is with Heroku and things like that. Imagine also how hard it can be for someone to be reallocated in the market. Like, if someone passed like 5-7 years working on deprecated software, and then suddenly he sees that he's completely out of market and try to become a Django developer. Imagine how much concepts we have in Django that deprecated software just don't have it. So that can be a really hard thing to be. Also, a lot of anxiety and depression. Technical debt brings a lot of weight to our lives as developers. Because if you are consistently dealing with bad code, a task that looks like, okay, that's a two-day task. When you start to dig in the code, you see that like 2 weeks, 1 month. So that's bringing anxiety for you, because you don't know when these kind of tasks will appear, or some bug, or some weird comport behavior on the application. So we start to get anxious because we don't know if something like that will come up over time. And a healthy growth doesn't make sense for a company to grow like 300% each year if our developer team doesn't scale and had the time and hands to work on that velocity. It's really common scenario for startups to glamorize excessive working hours because there were some high peak of purchase in the application, and then the dev needs to wake up like 3 in the morning on a Thursday just to restart the server because the memory was like out of quota. In a realistic and respectful world, pragmatic world, the machines could take care. Like if you have a load balancing before that, that could start and turn off some servers. So you don't need to be that person or that thing because the machine will do that. And as just said earlier, you are not going to be able to do cool things burned out. So you need to take care. And now, the Pizza Tower is now sustainable. This is one of the rare situations where a bug becomes a feature because it will not fail anymore, and it became a monument, like worldwide famous. And even though it's still leaning, but it's leaning on a controlled way, but not like because of everyone that tried to push it. It's because they engineered a solution that will hang that. And the same can happen with John's software. If we apply all those feasible solutions, we can have the same scenario on a sustainable software, which is the best case. And all those references that I used to wrote this talk is on this GitHub awesome list. The technical debt concept, the talk from G. Bay, Reisberg, everything, the book that I get, the impact, and also a lot of others reference, and I really would like for you to contribute it with some architectural and technical debt links with videos, talks, books, everything. So that's it. Thank you so much.